Hey everyone, welcome to week 2. If you're watching this, you guys are in my B cohort. Um, Today's video lecture, or the first video lecture I'm going to give for you for this week of remote learning, is something that some of you haven't seen. It's something that half of you have seen. Unfortunately, I was only able to finish this presentation in class with my red and orange classes. My purple and yellow classes haven't seen this. Even if you have seen this, if you are in that red or orange class, there's going to be some new information on the last few slides that will help you on an assignment that you'll have to do after this. So just because you're in those red and orange classes, don't just skip this video. Please watch. It'll be a good review. Um, for those of you in the yellow and purple classes, we obviously aren't going to do this presentation in class, so I'm still going to give you the notes. What I'm going to do is I'm going to fill them out for you, print them out, and then give them to you in class. Then we'll quickly review the presentation on Thursday, and then we'll get going on Unit 1. The next video lecture that I'm going to have you guys watch after this one is about our solar system, which should be a review, but I definitely want to cover that remotely, not in class, because on Thursday, second half of class on Thursday or Friday, I want to dive right into Planet Earth, which is Unit 1. So this video lecture is going to be on the scientific method. Like I said, some of you have already seen this, but please watch the full video, and let's get started. All right, so what is the scientific method? Well, the scientific method is a manner in which scientists can gather and organize information, and it helps them more easily answer questions about the world we live in. It's crucial that they follow this method and they organize their work. That way, other scientists can look at their work, try their experiments out for themselves, kind of piggyback on that work, and then keep making scientific discoveries and further the world we live in, further technology, further things like that. If you can see this image right here to the right of my head, it looks like a fairly linear process. The truth is that it's not a linear process. Oftentimes, scientists have to go backwards and repeat steps, or if they don't get the result they want, they totally have to go back, change what they're looking at, change what they think is going to happen, change some things about the experiment, and start from scratch. All right, so the first step of the scientific method is to make an observation or form a question. So this is what you want to learn. So you see something out in the world, you develop a question, and then you maybe want to pursue that a little bit further and kind of learn more about it. So once you have your idea, once you make your observation, once you have your question, then you need to do some research. It's tough to find anything out. It's tough to conduct an experiment with zero background information about whatever experiment you plan on conducting. So for these steps, I'm going to give you an example of an experiment, and hopefully that will help kind of solidify things for you guys. So an example of this would be if you were making a paper airplane. You threw the paper airplane, maybe it didn't go as far as you thought it would. So maybe your observation, your question you form is what makes a paper airplane fly further. So we made our observation, we have our question. Now we move on to step 2, which is to form a hypothesis. A hypothesis is just an educated guess. I'm going to move my head because it's going to be in the way of some writing in a few seconds. So your hypothesis is an educated guess, and your hypothesis is the predicted answer to whatever question you're researching. So in the case of this airplane, let's say that we think that adding weight will help it fly further. That's our hypothesis. We'll conduct an experiment by adding weight to a paper airplane and see if that indeed does make a paper airplane fly further. All right, so the third step of the scientific method is to perform your experiment. So we have our idea, we have our hypothesis, we think we know what's going to happen. Now we need to test it. So we're going to design a test or procedure to find out if our hypothesis is correct. We need to make sure this is as detailed as possible. That way, if we conduct the experiment, we get certain results. Maybe someone else wants to conduct the same experiment. If we write down our procedure, exactly what we did in great detail, they're going to be able to replicate that experiment and hopefully get the same results as you did. So if we're using the airplane experiment, once again, as our example, what we would do is we would make a regular paper airplane and we would throw it 3 times from a designated spot in a room, and then we would measure those throws. Then, after that, we would take the same paper airplane, we would add weight to it, we would go back to the same spot we did before, throw it 3 more times the same way we threw it the previous time, and then we would measure those throws and then compare the results. The fourth step of the scientific method is to analyze our data. So we conducted our experiment, we recorded data. Now we need to determine what that data means. So for example, if paper airplane 1, which was the regular airplane without any weight, flew an average distance on the 3 throws of 10 feet, compared to the second airplane, which we added weight to, if that flew an average distance of 7.5 feet, that's our data. We analyzed it. What does that mean? Well, after we analyze the data, we are then going to draw a conclusion based on that data. So once again, I'm going to move my head because I know it's going to be in the way very soon. So based on the evidence that we gathered in our experiment, we can determine whether our hypothesis was correct. Our hypothesis was that if we added weight to a paper airplane, that it would fly further. Based on the data, we can see that it did not fly further when we added weight. So we would reject our hypothesis, meaning that our hypothesis was incorrect. So maybe we would then go back to the drawing board, maybe try to determine what else makes a paper airplane fly further, and then once we decide on something, test that as well. So those are the 5 steps of the scientific method, and if followed correctly, your experiment is going to most likely turn out well. If it doesn't turn out well, like I said, you just go back to the drawing board and then you repeat the same steps until you get the desired result. So there are some other vocab words I want you guys to be familiar with when it comes to the scientific method or just experimental design in general. And those would be independent variable, which is a variable in an experiment that you manipulate. In this experiment, the independent variable would be the weight added to the airplane. The other variable that's important to know is the dependent variable, which is the variable in an experiment that you measure. So what's being measured in this experiment is the distance the airplane flies, which we concluded that when you add weight to an airplane, it doesn't necessarily fly further. And the last is the control variable or the constant. It's a part of the experiment that is kept the same. So things that we kept the same in this experiment were the method that we are throwing the airplane, the location of the throw, and then if, let's say, we had to make multiple airplanes, we should be folding those airplanes the same exact way every time. So that's the scientific method. Like I said at the beginning of this video, if you were in red or orange B, you have already seen this. You already have the notes for this. If you were in if you were in yellow or purple B, this is the first time you've seen this. You do not have the notes for this. I will give you the typed out notes in class on Thursday, and we will go over this. But the reason why I wanted to go over this now and review this for the people who have already seen it is because the activity that I have for you after this involves looking at some scenarios and identifying the dependent, independent, and the control in that experiment. So I wanted to do a practice round with you guys before you go out and do that. So let's take a look at this scenario. And down here. All right. So in this scenario, Billy wants to know what color of light plants grow best in. He hypothesizes that because plants are green, they will grow best in green light. He buys spinach seeds at the local store and plants them in various pots in his house. Billy hooks up lamps of different colors, yellow, purple, white, and green, above 4 of the pots, and he planted seeds in. He keeps the plants in the same room, keeps the temperature and humidity the same for all the plants, and waters the plants at the same time each day with the same amount of water. After 2 weeks, Billy measured all of his plants, and the results are as follows. The spinach he grew with the yellow light grew a height of 5.5 centimeters. The spinach he grew with purple light grew 12.5 centimeters. The spinach he grew with white light, and remember white light is all of the colors of light combined, grew 8 centimeters. And then the spinach he grew with green light grew 4.5 centimeters. So what can we say about Billy's hypothesis? He hypothesized that because plants are green, they will grow best in green light. We look at his results and we can see that after 2 weeks, the plants that were grown with green light actually grew the least. So we can definitely reject that hypothesis, and he might have to go back and try something new or just end the experiment completely. What was the dependent variable? Well, if you remember, the dependent variable is what's being measured. So what's being measured here is height. So the height of the plant after 2 weeks is the dependent variable. The independent variable, which is what is being manipulated, is the color of the light that the plants were grown in. So the yellow, purple, white, and green lights, those were all independent variables. And finally, once again, move my head. What was the control in this experiment? So the control is what's kept the same throughout the experiment. So the control was that he kept the plants in the same room. One wasn't in the dining room, one wasn't in the kitchen. They were all getting the same amount of light if there was windows in there. He keeps the temperature and the humidity in the room the same for all the plants. And then he waters the plants at the same time each day with the same amount of water to ensure that they all have the same opportunity to grow. Because if he watered one plant with a little bit more water, then his experiment, his data would not be valid. So the activity that I'm going to have you do now is a lot like this. So if you need to kind of circle back to the end of this video and rewatch this, I suggest you do that. I don't think the problems are that difficult. It is set up as a quiz on Google Forms, but it is not a quiz. It's just going to be a regular assignment, so don't worry about that. As always, if you have any questions, you can message me on Google Classroom or email me. Stay tuned for my next video, which is going to be on the solar system. But other than that, good luck, and I'll see you on Thursday.